Today, I will be covering a device-independent graphics imaging model for use with raster devices by John Warnock and Douglas K. Wyatt. This conceptual paper defines an imaging model that has profound and continuing impact on computer graphics and graphic design. This paper was originally published in 1982 when Warnock and Wyatt worked at the Xerox Palo Alto Research Centers, or PARC. At PARC, researchers were upgrading from their fixed-resolution black and white displays to new machines that supported a wide range of different color displays. Graphics that worked previously on the Alto did not scale properly to the new displays, and Warnock and Wyatt were hired to work on device-independent graphics that could properly display graphics on any raster device. Why was this so challenging? Well, raster devices encompass a large field. Raster graphics are defined by rectangular grids of pixels, but different screens can have different resolutions and color gamuts. Some are only black and white, while some can render gray values and others are in full color. Dot matrix printers also count as raster devices, so in effect, Warnock and Wyatt were designing an abstraction for both computer screens and printers. Thus, their work has massive implications for hardware engineers, operating systems designers, and even book publishers. However, raster devices do not cover all displays or printers. There are some non-raster devices, such as vector displays and pen plotters, that are not based on rectangular pixel arrays. In their paper, Warnock and Wyatt create a device-independent abstract imaging model so graphics can appear on any display with any resolution. Graphics that could be shown on the simple black and white displays of the old computers can now be displayed on any arbitrary raster medium, such as printers and different size screens, without issue, compensating appropriately for changing resolutions, aspect ratios, and color capabilities. To accomplish this, Warnock and Wyatt turned to an idea that has been around for millennia: screen printing. Just like how screen printers work their magic by pushing colored ink through a stencil onto paper, Warnock and Wyatt defined concepts of stencils and sources, only using digital ink instead of physical ink. Stencils are openings that obscure ink from the final result and come in two forms: shapes and masks. Shapes are closed curves that describe geometric shapes like triangles, ellipses, or any kind of parametrizable curve. Masks, on the other hand, are binary two-dimensional arrays, where zeros represent solid stencils that obscure ink and ones represent open holes that allow ink to pass through. Sources are analogous to the ink that screen printers push through to the final paper. Inks can be anything like solid colors, gradients, patterns, or even multicolored images. Warnock and Wyatt envisioned that their abstract imaging system will allow a programmer to display any arbitrary shape, pattern, or font using only a few simple interactions of digital components, stacking them up and pushing layers of digital ink through successive stencils, just like a screen printer. How do we display this on different devices? Warnock and Wyatt handled that as well, by creating coordinate systems for different devices and defining the process for mapping between different coordinates. Each device has its own unique device coordinate system, while the application itself deals with something called a virtual coordinate system. All systems designers had to do was develop their own mapping between the virtual coordinate system and the coordinates of the display system in order to display or render something onto the screen. How does this relate to text? Well, text just contains characters, and a single character is a simple rectangular clipping region with an artist-designed mask and a font color pushed through. And with those simple components, voila, a character on screen. Warnock and Wyatt understood the implications for graphic design and typography that they developed. Warnock later left Xerox PARC to form his own company, Adobe, and implemented the imaging model to create the first version of PostScript. In 1985, PostScript was used by Apple's LaserWriter, one of the first mass consumer printers, and this sparked a graphic design revolution, as anyone could now cheaply print pixel-perfect fonts and images to sheets of paper. Adobe continued to develop PostScript throughout the 90s and eventually released a successor in 1993 known as the Portable Document Format, or PDF. This 1982 paper has had outsized impact on modern concepts in digital graphic design. For instance, we still use shapes, masks, and clipping regions as terms in Adobe Photoshop and Illustrator due to their intuition and flexibility. I see Warnock and Wyatt's work as a manifestation of Vannevar Bush's vision of human-computer interaction and a refinement of Sutherland's Sketchpad graphical communication system. Because of PostScripts and Adobe's huge impact on making graphic design a computer-based job in the modern world, I think Warnock and Wyatt would make a fitting addition to the CS 191 curriculum.